Okay, so welcome back to chemistry. Last semester we ended finishing up through chapters 5 through 8. So just a couple of things that you need to remember coming into our new unit and how we're starting this semester. So remember we have cations and anions, and I'm going to go through this pretty quickly. I also put some video lectures of last semester, so if you needed a little bit more in depth, you could also look back on those as well. So if we look at this side of the periodic table, those are the metals. Metals, we know that metals form our cations. Cations are positively charged. So remember in group 1, everything here has one valence electron, so it'll take on a +1 charge, losing that one valence electron. +2 for group 2 and +3 for group 3. So hopefully this is sounding familiar. We did the representative elements, which were groups 1, 2, and then 3 through 7. Those were the representative because they represent the very same distinct patterns each time. Now coming over to anions, our anions were a little different because they're negatively charged. And so anions are going to be negatively charged, and they are going to make up this group over here, or the nonmetals. And remember, hydrogen gets to act as a metal or a nonmetal. Well, in group 7, because they're going to gain electrons, they're going to take on a negative charge. Group 7 is going to gain 1 electron. Group 6 is going to gain 2 electrons, and group 5 will gain 3 electrons. So that's one thing that you need to come in remembering or knowing. Now for making ionic compounds, remember the cation always comes first. So the cations, those are the metals. The metal is always first. And remember, a cation gets to keep its name. So magnesium stays magnesium in a compound. We're going to cross our charges, and when the charges are the same, we don't need subscripts. So I'm going to do some examples of this. Remember that the whole point of subscripts is to make the compound electrically neutral. The cation keeps its name, and the anion ends in IDE. So just a review or practice. If we look at this periodic table and we find calcium, calcium is right here, so it's in group 2. So we're going to take calcium, and we're going to say it's +2. And nitrogen is right here. It's going to take on a -3 charge. So nitrogen is -3. Remember that this 2 is going to drop down and become the subscript on nitrogen. And this 3 is going to drop down and become the subscript on calcium. So my formula is going to be Ca3N2. And I'm going to name that, the cation keeps its name, so it's calcium nitride. The ending will always end in IDE because the anion changes with an IDE ending. All right, magnesium and oxygen. So magnesium is in group 2. It's going to take a +2 charge. Oxygen is going to take a -2 charge. So because magnesium and oxygen are already electrically neutral, this and this add up to 0. We don't have to cross any subscripts. It just becomes MgO. And so when it does that, it becomes magnesium oxide. Okay, aluminum and sulfur. So coming over here, aluminum is right here. It's in group 3. So aluminum is going to take on a +3 charge. And sulfur is in this group right here, so it's going to take on a -2 charge. Remember, we're going to cross the number, not the charge. So our formula is going to be Al2S3, and we're going to name that aluminum sulfide. And finally, sodium and phosphorus. So sodium is in group 1. So we have Na. And phosphorus is over here in group 5, so it's going to take on a -3 charge. So -3. Again, my numbers cross. I never have to show a 1 in a formula. So it's going to be Na3 and then just P. So this 1, it just by having a P, it shows that we have 1 phosphorus. And then we name it sodium phosphide. Okay, at this point, that should be enough to do the questions for the breakout room, where you're creating a correct compound, which would be this right here, and then you're naming it. So there's a chart for you to do that. All right, let me know if you have questions.